Hello friend, today we are going to discuss about FMEA, failure modes and effects analysis. This FMEA is actually based on AIAG plus VDA version. AIAG is Automotive Industry Action Group and VDA is Barbender Automobile Industry. This FMEA first edition of the FMEA AIAG plus VDA is published on June 2019. Then what are the content we are going to discuss? That is the 7-step approach that in this session. And next is action priority like low, medium and high. And next is failure effects related to function of the process item and failure causes that related to function of process work elements, and what are the current prevention control of failure causes and what are the direction controls of failure cause and more, that we are going to discuss in details. First, what are the introductions? In introductions actually we know about the history and what are the uh, joining periods of AIG video, that's we are going to discuss. First, developed in 1950 by US military. First FMEA is developed in 1950 by US military. Now appropriated and used by NASA in 1963 for space program. And Ford was the first automotive FMEA in 1977 and incorporated in Big Three, that Automotive Industry Action Group AIAG and American Society for Quality Control, that's copyrights in 1993 and used by many industry sectors. Next is published AIAG 4th edition 2008. That is the AIAG based that's latest edition that was published in 2008. Now published jointly by AIAG and VDA, that's published in 1st June 2019. That is combined version of the AIAG and VDA both. First, Automotive Industry Action Group AIAG and Barbender Automobile Industry, that is Germany, associated for the automotive manufacturer and supplier, issued the first edition of joint FMEA book. And new AIAG VDA FMEA handbook was released in June 2019. Linkage of IATF 16949 2016. The goal of IATF or Automotive Quality Management System is to develop QMS that provide for continual improvement, emphasizing defect prevention, reduction of the variation, reduction of the waste in supply chain. Next is process failure mode and effect analysis in a team-oriented, systematic, qualitative, analytical method intended to evaluate the potential technical risk of the failure of process and analyze the cause and effect of those failures. Next is document preventive and reactive actions like recommended action to reduce the risk. And what is the FMEA actually? FMEA mean to before the events, means before the event we need to take actions and not an after the fact exercise. To achieve the greatest value, the FMEA is conducted before the implementation of product and process in which failure was potentially exists. Now, next is FMEA as a risk management tool. If we are going to discuss about FMEA as a risk management tool, then we think about technical risk. What are the technical risks that are included in FMEA scope? And what are the financial risks that are out of scope? And time risk, strategy risk, these terms are the out of scope. Now next is what are the applications of FMEA, that is in case of new design, new technology, new process, new application of existing design, that is case 2. Case 3 is engineering changes to an existing design or process. Next is limitations of FMEA. Actually it is qualitative, that is subjective terms, not quantitative, and it is a single point failure analysis, not a multi-point failure analysis. It relies on the team's level of knowledge, which may or may not predict future performance. It is a summary of the team's decision and discussion and decision. Therefore, the quality of the FMEA is subject to the recording skill of the team, which may reflect the discussion point in whole or in a part. Means it is not a transcript of a meaning. Now, next is the benefits of the FMEA, that is direct improvement and indirect improvement. Direct improvement in safety and quality, reliability, manufacture reliability and service reliability. That's thereby reducing warranty and cost. Indirect improvement, that is reduction of the late changes, defect-free product launches, and build up knowledge base and regulatory compliances, thereby improving customer satisfactions. Now next is, what are the customers? Define the customer. There are 4 customers that considered in FMEA process. First is end user. End user, the person or organization that utilize the products. Second is OEM assembly and manufacturing center plants. That OEM assembly actually is a location where manufacturing operation like stamping, powertrain and vehicle assembly can take place. Addressing the interfaces between the products and assembly processes is critical to an effective FMEA industry. Next is supply chain manufacturing. Supply chain manufacturing is the location where manufacturing, fabrication, assembly of production material or parts take place. In OEM assembly, in assembly of vehicle takes place, and in supply chain manufacturing, assembly of material or parts takes place. Regulators, government agencies that define requirement and monitor compliance to safety and environment specification which can impact the product or process. Now next is the 7-step approach in FMEA. That first step is planning and preparation, second is structural analysis, third one is functional analysis, and fourth is failure. First is planning and preparation, second is structure, and third is functional, fourth is failure analysis, fifth is risk analysis, and sixth is optimization, seventh is result documentation. Now first step 1, that is planning and preparation. In step 1, process FMEA header. These are the terms we need to fill, like company names, like plant location, customer name, models year, and what are the subject, FMEA start date, FMEA revision date, cross-functional teams name, and FMEA ID number, process responsibility, and confidentiality label. Now FMEA is recommended that the 5T method, that is intent, timing, team, task, tool, that we should need to consider during the developing of PFMEA. Once we need to develop first DFMEA. In 5T method, intent, timing, team, task, and tool, that concept need to introduce. Now next step is structure analysis. After planning and preparation, we need to analyze structure. What are the structure analysis? Actually, purpose of process structure analysis to identify and break down the manufacturing system into process item, process work, process step, and process work element. Structure analysis is break down the 3 terms, that is process item, process step, and process work element. Now step 2, that is in AIAG, that was the process steps and functions, and in new FMEA AIAG plus video version, that is now breakdown in, that is step 2, that is process item, process step, and process work element. Now means process steps in AIAG FMEA is now breakdown into 3 terms, that is in FMEA AIAG plus video version, that is process item, process step, and process work element. Now next is function analysis. The purpose of the process function analysis is to ensure that the intended functions requirements of the product and process are appropriately allocated. Now, we have already defined planning and preparation and structure analysis. These structures, what are the functions? Means what are the function of the process item, process steps and process work elements? We are defined in this step. In AIAG FMEA version, that was function, only written function. Now it can divide it into function of the process item, process work elements, process steps and process work element and process characteristic. Means function is now divided into three terms, that is function of the process item, function of the process steps and product characteristic, and function of the process work element and process characteristic. These three terms. Now next step is failure analysis. Now failure analysis is also divided into in AIAC. That's what the failure analysis, that is potential failure analysis, modes and potential failure effects. Means that mode, what are the effect as individual and what are the severity, class and potential causes. Means failure modes, failure effect, potential effect of failure mode and severity. Then next is potential causes of failure. Now these terms now are divided into, in video version, that divided into, that is failure effect first one, then severity of failure effect, then failure mode of the process step and failure cause of the work element, process work element. Means failure effect of function of the failure effect is function of the process item like system, subsystem, like that, components. Means failure effect is of the process, function of the process items. Means function of the process, systems, subsystem and component. Now next is the effect, that is severity of failure effect. Now second term is failure mode, that related to failure mode of the process, function of the process step, and failure cause of the work element is the failure cause during the function of the process work element and process characteristic. Now these are the failure analysis, in which purpose of process failure analysis is to identify causes, mode, effect and their relation to stable the risk assessment. Now this is the failure chain actually, in which failure mode is center, what happened is the failure effect, and failure cause means why this failure occur, that is failure cause. Now next is customer, that is internal customer, external customer, legislative, product and individual operators. Now next is the failures effect are given in severity rating according to your plants, ship to plant, individual. Now we need to prepare some questions in failure analysis, like does the failure mode physically impacts downstream processes or cause potential harm or equipment or operator. Next is what is the potential impact on the individual, and what would happen if a failure effect was detected prior to reaching the individual. These are three questions. Now what is failure modes and what are their effects and what are the potential causes, we need to study. Like what is the failure mode? Failure mode actually a process. Failure mode is defined as manner in which the process could cause the product not to deliver or provide the intended functions. Means process failure mode is a manner in which process could cause the means process cannot process is failed to meet the process requirements. Now, there are several categories of potential failure modes like loss of process function, operation not performed, partial function, incomplete operation, degradation of process function, overachieving of process function, wrong parts installed, and some of the typical process failure modes that but not limited to hole too shallow, dirty surface, surface finish too smooth, that are. Now next is failure cause. A failure cause is an indication of why a failure mode could occur. The consequences of a cause is the failure mode is identified to the extent possible every potential manufacturing assembly cause for each failure mode. Now next is failure analysis, that is what are the effect of the failure effect, second is failure modes, and next is failure cause. Now failure effect of the failure associated with next higher level elements are inducer in the function analysis. Means in function analysis what are the effect of failure and failure modes. The modes of or type of failure associated with the focus element in the function analysis. Next is the failure causes. The cause of failure associated with the work element and process characteristic in the function analysis. Now next is step 5, that is risk analysis. In risk analysis, in previous AIAG version, that is that was severity, class, and potential causes of failure. Means what are the severity, potential causes, occurrence, current occurrence controls, current prevention control, current detection control, this type like detection and RPN rating. Now in new FMEA, that is AIAG and VDA version, in which step 5 risk analysis, we are doing current prevention control of potential causes and occurrence of the potential causes, that ratings, and next is the current detection controls of potential cause and failure modes, and detection ratings of the potential cause and failure mode, and action priority, and next is a special characteristic, and if any FMEA code that also need to mention. Now in risk analysis, the purpose of process risk analysis to estimate risk by evaluating severity, occurrence, and detection in order to prioritize the needs for action. We need to focus on severity, occurrence, and detection. Now our next action is that is current prevention control and detection control. These are terms in risk analysis. Now what is the current detection control? In detection control, actually current detection control detect the existence of a failure cause or failure mode both, either by automatic or manual method before the item leaves the process or is shipped to customer. Like some example is like visual inspections, like visual inspection with sample checklist, optimal or optical inspection with camera, or optical test with limit sample, attribute test, dimension check with caliper, like this. Next is current prevention control. Current prevention control is in two terms. First is process planning, second is production process. Process planning, current prevention control facilitate optimal process planning to minimize the possibility of failure occurrence. Prevention of possible layout deficiencies of the production facilities, like test run according to the startup regulations. And next is production process. In terms of production process, the definition of current prevention control is eliminate. Purpose of the current prevention control is to eliminate or prevent the failure cause or reduce its rate of occurrence, and prevention of defectively produce product in the production facility. Some example is like two-hand operation of machine, subsequent part cannot be attached, like poke-oka, form depend position, equipment maintenance, operator maintenance, and work instruction, visual aids, machine control, first part release, like that. Next is severity. Severity is actually we are going to evaluation. In evaluation, we need to evaluate the severity, occurrence, and reduction. In severity stand for the severity of the failure effect. Occurrence stand for the occurrence of failure cause, and reduction stand for the reduction of occurrence, failure cause, or failure mode, both. Now this is the tables of the severity. In already I have made a video of the severity, occurrence, and reduction table. That's we are going to refer that table, and in this session we are just overview that table. That is the severity tables, in which 10th is high impact, 9 and 10th is high impact, and 8 and 7 is moderate high. In high impact means impact to your plants, impact to ship to plants, and impact to end user. This term we are going to discuss. Means is rating is 10, then failure may result in the and acute health and safety risk for the manufacturing and assembly worker. Next ship to plant is same, and that also end user. And next is in case of 9 rating, failure may result in the plant regulatory non-compliances, and ship to plant is failure may result in regulatory compliance and impact to end user, that is non-compliance with regulations. Now in case of ratings 8, that impact to your plant is 100% of production run affected may have to be scrapped. Means production may be run, and maybe 100% may be production run, and that affected may have to be scrapped. And next is in ship to plant, that line is shut down greater than the full production stop shipment, like this. And impact to end user, like loss of primary vehicle functions. And in case of rating 7, that production may have to be sorted, and a portion less than 100% may be scrapped. And in case of impact to ship to plant is line shut down from 1 hour to full production ship, maybe. And impact to end user, that is degradation of primary functions. Next is in case of rating 6, 5 and 4, that are the moderate low rating. In case of rating 6, 100% production run may have to be rework offline and accepted. Offline rework. Now ship to plant, lines are down or up to 1 hour, and impact to end user, loss of secondary vehicle functions. In case of rating 5, a portion of production may have to scrap offline, and impact to ship to plant, that is less than 100% of product affected, or strong possibility of additional defective product sort required, and no line shutdown. And impact to end user, that is degradation of secondary vehicle function. Next is rating 4, that is impact to your plant, that 100% of production run may have to rework in station before it is processed. And impact ship to plant is, that is defective product trigger significant reaction plan, additional defective product not likely, sort not required. Impact to end user, very objectionable appearance, sound, vibration, harshness, like that. Next is rating 3 and 2, that is low effect And in case of rating 3, a portion of the production run may have to rework in station before it processed. And impact to SIP2 plant, that is defective product trigger minor reaction plan, additional defective product not likely, sort not required. And impact to end user, moderate objectionable appearance, sound, vibration, harshness. In case of rating 2, slight inconvenience to process, operation or operator. And impact SIP2 plant is, that is defective product trigger no reaction plan, additional defective product not likely, sort not required, required feedback to supplier. And impact to end user, that slightly objectionable appearance, sound, vibration, harshness, or that is haptics. Next is in case of rating 1, that is effect is very low, that no discriminable effect. And these are for the impact to your plant and SIP2 plant and end user. Now occurrence table. The occurrence rating describes occurrence of failure cause in the process, taking into account to associated current prevention control. Now occurrence table, the rating, determining the rating, the question such as following should be considered. What is the equipment history with similar process and process step? What is the field experience with similar process? Is process or carry out similar to previous process? How significant changes from the current production process? Is the process completely new? What are the environmental changes? A best practices already implemented. Now next is occurrence rating. That is occurrence rating. In case of occurrence rating, now what are the prediction of failure causes and what are the prevention controls? Like in case of rating 10, that is extremely high, that potential control is no prevention control. And in case of rating 9 and 8, that is very high, that prediction of failure cause occurring is very high. And prevention control is, prevention control will have little effect in the preventing failure cause, little effect. In case of rating 7 and 8 of occurrence, that is effect failure cause occurring effect is high. And in case of rating 7 and 6, and type of control is behavioral or technical control. That's prevention control is, prevention control somewhat effect is preventing failure cause. And in case of rating 5 and 4, that is moderate, and that prevention control are effective in preventing failure cause. And in case of rating 3, that occurring effect is low, that best practices behavior are technical, that prevention control are highly effective in preventing failure cause. And in case of rating 3 and 2, 2 is, that is very low, that is also best practical control and behavioral or technical control, that prevention control are highly effective in preventing failure cause. And in case of rating 1, that is extremely low, that type of control is technical control, and prevention control is, prevention control are extremely effective in the preventing failure cause from occurring due to design or process or tooling designs or fixture designs and or intent of prevention control. Failure mode cannot physically produce due to the failure causes. Means failure mode cannot be produced. That is rating is 1. And rating 2 is, 2 and 3 is that prevention control are highly effective in preventing failure. Rating 4 and 5 is prevention control are effective in preventing failure causes. Rating 6 and 7, that is preventive control somewhat effective in preventing failure causes. And in case of rating 8 and 9, that is preventive control will have little effect in preventing failure cause. And in case of rating 10, that is no prevention control. Now next is deduction table. Deduction table is the rating associated with a prediction of the most effective control from the listed deduction type process control. Deduction is relatively rating within the scope of the individual FMEA and is determined without regard for severity or occurrence. Deduction should be estimated using the criteria in table. Now, deduction control started from when the production is identified at discrepant to the point of final disposition. These control usually expected control that are used for discrepant product with higher deduction rank. After implementation of any unproven control, the effectiveness can be verified and re-evaluated. In determining this estimation, questions such as following should be considered. What test is more effective in the detecting the failure cause or failure mode? What is the usage profile or duty cycle required, and what sample size is required to detect the failure, and what is the test procedure proven for detecting this cause and failure mode. Now, next is deduction table. Deduction table rating is 10th and 9th. That ability to detect is very low. In case of rating 10, that opportunity for deduction is the failure will not or cannot be detected. And in case of rating 9, the failure mode is not easily detected through the random or sporadic audit. And in case of rating 8, human inspection like visual, tactile or use of manual gauging, attribute or variable that should detect the failure mode or failure cause. And in case of rating 7, that machine based detection like is automatic or semi-automatic with notification by light, buzzer like or use of inspection equipment such as coordinate measuring machine that should detect failure mode or failure cause. That is deduction type controls. Deduction type controls in rating 8 and rating 7. Rating 8 is human and rating 7 is machine based. And in case of rating 6, that is human inspection, visual, tactile or use of gauging, manual gauging like attribute variable that will detect the failure mode or failure causes. That will detect the failure mode or failure causes, including product sample check. In this, product sample check is also included in case of rating 6, and in case of rating 5, product sample is also included in machine based detections. And in case of rating 4, machine based detection, machine based automotive detection method that will detect the failure mode downstream and prevent further processing to system, or system will identify the product as discrepant and allow it to automatically move forward to process until the discrepant rejection unload area, and discrepant product will controlled by the robust system that will prevent outflow of the product from the facility. Now, next is rating 3, that is also ability to detect is high, and opportunity for detection is machine based automatic detection control that will detect the failure mode in station and prevent further processing, or system will identify the product are discrepant and allow it to automatically move forward in the process until the designed rejected unload area. And discrepant product will be controlled by a robust system that will prevent outflow of the product from the facility. Now next is rating is 2. In case of rating 2, machine based that detection method that will detect the cause and prevent the failure mode. Now next is rating 1, that is very low, that is failure mode cannot be physically produced as designed or processed, or detection method proven to always detect the failure mode or failure cause. Now next is action priority. Once the team has completed the initial identification of failure mode and effect, cause and controls, including rating for severity, occurrence and reduction. They must decide if further effort are needed to reduce the risk. Now, due to the inherent limitations on resources, time, technology and other factors, they must choose how to best prioritize these efforts. Now, action priority method is introduced and it accounts for all 1000 possible combination of yes, O and D, severity, occurrence and reduction. It was created to give more emphasis on severity first, then occurrence, then reduction. The logic follow the failure prevention instead of FMEA. The action priority offer is suggested a high, medium, low priority for actions. Companies can use a single system to evaluate action priority instead of multiple system required from multiple customers. Now, risk action priority, that in action priority, risk priority number, that is RPN, are product of SOD and range from 1 to 1000. Thus, RPN are used in FMEA AIOZ version. In video version, we are using action priority. The RPN distribution can provide some information about range of rating, but RPN alone is not adequate method to determine need for more actions, since RPN give equal weight to S, O and D. For this, the action RPN could result in similar risk number in very different combination of SOD, leaving the team uncertain about how to prioritize. Means RPN cannot give the prioritizations, and RPN cannot describe how to focus first, means how to focus first on severity and then occurrence, then reductions. When using RPN, it is recommended to use additional method to prioritize, like RPN results such as yes and O combination. The use of a risk factor number RPN threshold is not recommended practice for determining the need for action. The RPN and SO method are not included in these publications. Now, action priority. Since the action priority table was designed to work with the severity, occurrence and reduction table provided in this handbook, and if organization choosing to modify the SOD table for a specific product, process or projects, the action priority should also be carefully reviewed. Action priority ratings are same for DFMEA and PFMEA but different for FMEA MSR. Now, priority high is what? Highest priority for review and action. This is priority for the taking actions, that is highest. The team need to either identify an appropriate action to improve prevention and reduction control, or justify the document where current control are adequate. Now, next is priority medium. Medium priority means we need to medium priority for review and action. And next is priority low, that is low priority for review and action. They should identify action to improve prevention or reduction control. It is recommended that potential severity of 9 and 10 failure effect will action priority high and medium. At the minimum, be reviewed by the management, including any recommendation action that were taken. This is not the prioritization of high, medium or low risk. It is the prioritization of need for action to reduce that risk. What are the need for action? That is high risk, low risk and medium risk. And action is in high risk, we need to take action. We need to prioritize to take more first on that high risk, and after that on medium risk, and after that on low risk. Means this is not prioritization of high, medium, low risk. It is the prioritization of need for actions to reduce risk. Now, this is the some combination of severity, occurrence and reductions that already I have explained in separate video. That link we will provide and you can go through. Like first combination is severity, in case of severity 9, 10th, and different combination of the occurrence, that is 9, 10th, that 6, 7, that is 8 to 10, that is 6, 7, 4 to 5, and 2 to 3, and 1. These are the combination. And next is the deduction combination, that 7 to 10, that 5 to 6, 2 to 4, 1, 1. And these are the combinations that action priority given that is high, medium, risk, low, like that. Now next is the step 6, that is optimization. In AISD 4th edition, that recommended actions and responsibility, target completion date, and action results, that action taken, like revised severity, occurrence, detection, and their RPM. That was in AISD 4th edition. Now in new FMEA AISD video version, now optimization step is what are the prevention action, detection action, and responsible person name, target date of completion, what are the status, action taken with pointer to evidence and completion date, and what are the revised severity rating, occurrence rating, detection rating, and special product characteristics if any, and what are the FMEA action priority of the severity, occurrence, and detections. Now in optimization, our purpose is of the process optimization step is to determine action to mitigate risk and assess the effectiveness of those actions. The end result is a process which minimizes the risk of producing and delivering product that do not meet the customer and stakeholder expectations. Main objectives of process optimization are identification of action necessary to reduce risk and assignment of responsibility and deadline for action implementation. Implementation and documentation of action taken, including confirmation of the effectiveness of implemented actions, and collaboration between FMEA team, management, customer, and supplier regarding potential failures. This is for reinforcement of product and process requirement and prevention and detection control. Now next is the result documentation. Step 6 was the optimization. That's we need to mitigate the determine the actions to mitigate the risk and assess the effectiveness of those actions. Now next is result documentation. Now we need to prepare the documentations, like what are their results, FMEA review results, that we need to maintain in this step, like what are the planning and preparation, step 1, step 2, step 3. Step 2 is structure analysis, step 3 is functional analysis, step 4 is failure analysis, 5th is risk analysis, and 6th is optimizations. Now the purpose of the result documentation step is to summarize and communicate the results of the failure mode and effect analysis activity. What are the results of failure modes and effect analysis activities? The main objective of process optimizations or process results documentations are is communication of results and conclusion of the analysis, stabilizing of action taken, and communication of action taken of reduce risk, including within the organization and with the customer and supplier as appropriate. And next is record of risk analysis and risk reduction to acceptable levels. Now FMEA report, the scope and result of FMEA should be summarized in a report, and report can be used for communication purpose within the company, between companies, and report is not meant to replace review of FMEA detail when requested by management, customer, or supplier. It is meant to summary for the PFMEA team and other to confirm completion of each of the tasks and review the results of the analysis. Now the results documentation, the layout of the documentation may be company specific. However, the report should indicate the technical risk of failure as a part of development plan and project milestone. The content may including the following: the statement of the final status, the summary of the scope of analysis, identify what is new, summary of how the functions were developed, a summary at least the high risk failures as determined by the team, and high risk failure including status of those actions, and a plan and commitment of timing for ongoing FME improvement actions. Thank you very much. Please like and subscribe the content. Thank you very much.